Hello guys, welcome to our class today, and we're going to tackle the mole. This is the most important unit and a basic pillar of chemistry. So we're going to start basically and summarize what you need to know in the mole. So what is the mole? Mole is the amount of substance that contains Avogadro's number of particles. The mole is the amount of substance that contains Avogadro's number of particles, which the particles can be ions, can be molecules, can be atoms, can be electrons. These particles we are talking about, they can be ions, they can be molecules, these are ions, molecules, atoms, and electrons. So the mole is the amount of substance that contains Avogadro's number of particles. These particles can be ions, molecules, atoms, or electrons. And the number of particles that Avogadro's number of particles contains is 6.023 times 10 power 23 particles. These particles can be ions, can be molecules, can be atoms, can be electrons. Therefore, in short, what am I saying? 1 mole of a substance is equal to 6.023 times 10 power 23 particles. Therefore, as you know, a dozen contains 12 items. A tray of eggs contains 30 eggs. A crate of soda contains 24 sodas, and one pair is 2 items. So also chemists use this universal thing to equate particles. So therefore, particles that 1 mole of a substance contains is 6.023 times 10 power 23 particles. So therefore, the mole is the amount of substance that contains Avogadro's number of particles. That is the mole. Very good. So we can do with that. So Avogadro's number of particles is the mole. And therefore, I'm going to summarize. So mole contains Avogadro's number of particles, which are ions, molecules, atoms, and electrons. And these particles are 6.023 times 10 power 23. So therefore, we have states of matter. We have solids, we have liquids, or gases, and we have gases. So I'm going to reveal the secret for you to know these 3 things. So for solids, we have a formula how to find moles. In liquids, we have formulas to find the number of moles. In gases, we also have the formula to find the number of moles. So I'm going to start from solids. And solids, if a substance is a solid, therefore we use mass to find number of moles. So in solids, moles, I'm going to use small m. Moles is equals to mass over molar mass. Mass over molar mass. That is the moles. You find moles, you can draw a triangle. For me to find moles is mass over molar mass. And what is molar mass? What is molar mass? Molar mass is the mass of 1 mole of a substance. For example, for 1 mole of sodium is 23 grams. That is 1 mole of sodium. 1 mole of iron is 56 grams. 1 mole of phosphorus is 31 grams. So 1 mole of phosphorus. So molar mass is the mass of 1 mole of a gas. Is the mass of 1 mole of a gas. Therefore, generally, the formula that is important here, finding mole if you have a solid substance, is mass of a molar mass. That's how we find moles. If you have, for example, mass of sodium is 12 and molar mass is 23, we can find moles. So this is a very important formula in calculation of moles if a substance is a solid. Let's go to liquids or solutions here. Let's go to liquids or solutions. In liquids or solution, how do we find moles in liquids or solutions? Liquids or solutions. So we can prepare solutions and we use molarity in this case. So what is molarity? We're going to start, if for example we dissolve sodium hydroxide pellets in water, we are going to use concentration, which is molarity. This is the universal molarity. What is molarity? Molarity is the concentration in moles per liter. Molarity is the concentration in moles per liter. Molarity is the concentration in moles per liter, denoted by moles per liter, or number 2, moles per dm cubic, or it can be denoted by molar, capital M. So we have 3 denotation of molarity. Molarity means is the concentration in moles per liter. That is molarity. And formulas to calculate molarity, I'm going to use capital M. Molarity capital M is equals to moles times 1,000, which is in centimeter cubic, over volume, which is also in centimeter cubic. Another way of finding molarity is grams per liter. Over RFM. Grams per liter over RFM. Another way of finding moles, from this you can make moles subject to the formula. You can find moles small m is equals to molarity. These are very important formulas. Times volume, which is in centimeter cubic always, over 1,000, which is in centimeter cubic also. So these are the formulas that are used to calculate moles in solutions. We were from solids, now we are in solution. Roman 1 was in solids, now this is Roman 2. This is liquids or solutions. These are very helpful notes to help you calculate the number of moles in solutions. And finally, let's go to gases. After finishing solutions. Let's go to gases. Very first. Let's go to gases. In gases, move closer this way. In gases now. So therefore in gases, we're going to gases. Gases, we use something known as molar gas volume. Molar gas volume, mgv. What the gas occupies at standard conditions. What the gas occupies at standard conditions. We are going to start from the first one, STP. STP means standard temperature and pressure, which is 0 degrees Celsius and pressure is 1 atmosphere. So 0 degrees Celsius and standard temperature and pressure. So 0 degrees Celsius is the temperature and 1 atmosphere is the pressure. So 1 mole of any gas, 1 mole of any gas, let it be hydrogen, let it be oxygen, let it be ammonia, 1 mole of any gas occupies 22.4 liters, which is the same as 22.4 dm cubic, which is the same as 22,400 centimeter cubic or ml. So 1 mole of any gas at STP occupies this volume, 22.4 liters, 1 mole of any gas. And another standard molar gas volume is the volume occupied by 1 mole of any gas at standard conditions. And these standard conditions is number 1, standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere. Roman 2, we have RTP. RTP means room temperature and pressure, and STP means standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere. And now let's go to Roman 2, the standard conditions, which is RTP, room temperature in the house during the day. What volume does 1 mole of a gas occupy? 1 mole of any gas, 1 mole of any gas, let it be hydrogen, let it be carbon dioxide, let it be ammonia, these are gases, occupies 24 liters, which is the same as 24 dm cubic, which is the same as 24,000 centimeter cubic. 24,000 centimeter cubic. So we have dealt with solids. In solids, how we find moles. We have dealt with solutions, how we find moles. And we have dealt with gases, how we find the number of moles. The 3 states of matter. That is the secret for us to find the moles. After that, you must know to write the equation of any reaction, use the ratios, and nothing will be difficult in moles. This topic is very challenging to students, but if you use this way, surely now you're going to succeed in the calculations of moles. Thank you. Let's meet in our next class so that we can do many calculations on moles so that we can get to understand the mole. Keep watching to my channel, follow the units and the topics and the subtopics that I'm going to be solving and the challenges so that you can be able to get to understand. Thank you. Let's meet in our next class.